warahmatullahi wabarakatuh. Hi everyone, let me introduce myself. My name is Rika Khairunnisa. I am from 3A, Math Education. Now I will explain about mathematical induction. So, let's start begin. Now I will explain about mathematical induction. Mathematical induction is a special way of proving things. It has only two steps. Step 1, show it's true for the first one, and step 2, show that if any one is true, then the next one is true, and then all are true. And next, principles of simple induction. First is let positive integer Pn be the statement regarding, and second, we want to prove that Pn is true for all positive integers n. And the third is to prove this statement. We only need to show that first P1 is correct, and if Pn is true, then Pn plus 1 is also true for every n greater than 1. And next is the induction principle method. Let Pn be a numbered statement round, and we want to prove that Pn is true for our integers n greater than no. To prove this, we just have to show that first Pno true, and second, if Pn are true, then Pn plus 1 is also true for all integers n greater than no. And I will explain about step 1 and step 2. Step 1 is called basic induction, meanwhile step 2 is called the induction step. The induction steps contains assumption, presumption, state that Pn is true. This assumption is called the induction hypothesis. When we have shown that two steps, right, then we have proven it. Pn is true for all positive integers n. Mathematical induction acts like a domino effect. Now I will explain about the example of mathematical induction. For all n non-negative integers, prove with mathematical induction that 2 to the 0 plus 2 to the 1 plus 2 to the 2 plus 2 plus 2n equals 2 to the n plus 1 minus 1, and the solution has two steps. Step 1 is introduce basic for n equals 0 non-negative integers first. We get 2 to the 0 equals 2 to the 0 plus 1 minus 1. This is clearly true because 2 to the 0 equals 1. Are 2 to the 0 plus 1 minus 1. 2 to the 1 minus 1. 2 minus 1. And 1 equals 1. 1 equals 1 have to. The principles are mathematical induction. P1 are true. And the second step is step induction supports that Pn is true. 2 to the 0 plus 2 to the 1 plus 2 to the 2 plus 2 plus 2n equals 2 to the n plus 1 minus 1, all true. And there we will see Pn are true. And then we have to show that Pn plus 1 is also true. That is 2 to the 0 plus 2 to the 1 plus 2 to the 2 plus 2 plus 2 to the n plus 2 to the n plus 1 equals plus 2 to the n plus 1 minus 1. What is the correct? We will also true. This is visual as follows: 2 to the 0 plus 2 to the 1 plus 2 to the 2 plus 2 plus 2 to the n plus 2 to the n plus 1 equals, in a bracket, 2 to the 0 plus 2 to the 1 plus 2 to the 2 plus 2 plus 2 to the n plus 2 to the n plus 1. And then the induction hypothesis is 2 to the n plus 1 minus 1 in a bracket plus 2 to the n plus 1. And there are 2 to the n plus 1 plus 2 to the n plus 1 in a bracket minus 1, because the 2 to the n plus 1 and 2 to the n plus 1 we will the same constanta. And then we will are equals 2 times 2 to the n plus 1 minus 1 and equals 2 to the n plus 1 minus 1. And the answer is 2 to the n plus 1 minus 1. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.